Hi guys, good morning. So in today's daily LeetCode challenge, we have this question: maximum number of moves in a grid. So we are given a grid, and we can start traveling from any cell in the first column, and from any cell we can go in either upper right, or lower right directions. Okay, and this is the first condition, and second condition is while traversing, the value of the next cell should always be greater than the previous cell. We can go from 3 to 4, okay, but we cannot go from 5 to 4 because 4 is lesser than 5, right? So these are the two conditions. So by following these two conditions, we have to traverse the grid, and we have to return the maximum number of moves that we can make. Let's do a dry run on the first grid to understand it, right? So if we start from the first cell, then we can go either here or here. Let's say we go here, then we can go here. We cannot go here because 2 is smaller than 9. We cannot go here because 3 is smaller than 9. But what we can do is we can go from 9 to 11 and make 3 moves. Even if we go in this direction, we can still make 3 moves. So for the first cell, the maximum number of moves we can make are 3, right? You can try dry running on other cells as well. I have already run. You will not get more than 3. Now let's talk about the second grid. From the second grid, from any of the cells in the first column, we are not able to make any move because see 2 is less than 3, so it is not possible. Here 2 is not greater than 2, so this is also not possible, not possible, not possible. So in the second cell, the maximum number of moves we can make are 0. Okay, so now how we'll solve this problem? So what we can do is we can start from each cell in the first column and traverse the grid and calculate result for each cell, and then we'll take the maximum result and return it. So one thing to notice is, like, we can travel, if we start from this cell, we can visit the upper cell in this way also and directly this way also. So basically what I am trying to make you understand is that there are we can reach the same cell from different directions, right, from different paths. So this is a DP problem. Whenever there are overlapping problems, then we can assume that this is a DP problem. So what we can do is we will memorize the result for each cell in a DP array to reduce the time complexity. So let's say we went in this direction and we found out the result for this cell. We'll memorize the result so that next time when we reach this cell, we can directly return the result for this cell. So let's start coding it up and then you will understand in a better way. So let's take the DP array. These M and N are for the length of row and column of the grid. Actually, you can avoid taking these as global variables. I am just too lazy to pass them in the function, so I just initialize them globally. You can directly pass them in the method. So here what we did was we iterated on the row because the column is constant, right? So we'll always start from the first column. So column is always 0 and row we are iterating on. Okay. And then we are taking the maximum result out of all and returning it. Now the main thing is how to write the memo solve function. So this I and j are nothing but row and column. If the result for that cell is present in the DP, then present in the DP array, then we will directly return the result, right? Now the main thing starts. So we can either travel in upper right or lower right direction. So if traveling in upper right is possible, that is, if we travel in the upper right direction and don't go outside of the grid, right? This is just to check that we remain inside the grid. Next thing what we'll have to check is that the next cell, the value in the next cell is greater than the current cell, right? Grid of I minus 1 j plus 1 greater than the value in current cell. In this case, we'll update res as 1 plus. Then if this condition is possible, then we can make one move, right? One move to that cell. So res will be 1 plus memo solve of I minus 1 j plus. So one move we are able to make, and the rest of the moves will be returned from this function, right? So similar things we'll have to do for other directions. So now let's write for right direction. So for right direction, we'll only move to the right column, right? So j plus 1 should be less than n, and the second condition is same. Now res will be equal to mat.max of previous res and current result, right? Similarly, we'll write for the last direction, that is lower right direction. Now we'll store the result in the DP array and return the result, right? So let's run and see. Okay, so the bug is the next cell should be greater than the previous cell. Here I have used greater than, but in the next two lines I have used less than. So this should work now. So I think this will work, but we can make the code a bit concise and directly return from here. I like to make my code concise. Okay, let's submit. Okay, so yeah, faster than 100%. Like if you like the video. Bye bye.